Good morning, Sir Nigapatan. Today I'm going to discuss composite sailing. So, what is composite sailing? Composite sailing, a modification of great circle sailing used when it is desired to limit the highest latitude. The composite track consists of a great circle from the point of departure and tangent to the limiting parallel, a course line along the parallel, and a great circle tangent to the limiting parallel to the destination. Composite sailing applies only when the vertex lies between the point of departure and destination. Composite sailing problem solving. From lat 30 degrees 50 minutes north, long 70 degrees 40 minutes west, to lat 40 degrees 30 minutes north, long 5 degrees 20 minutes west. The maximum latitude to be is 45 degrees north by composite sailing. So our L1 is 30 degrees 50 minutes north, and our L2 is 40 degrees 30 minutes north, and our latitude vertex is 45 degrees north. Our long one is 70 degrees 40 minutes west, and our long 2 is 5 degrees 20 minutes west. So before we start, we need to find the difference of longitude. So since they're both west, we need to subtract it. So the answer will be 65 degrees and 20 minutes east. So first we're going to find the P1. And the formula is cos P1 is equal to tan L1 divided by tan LV. So tan 30 degrees 50 minutes divided by tan 45 degrees will be 0.596908,429, and shift cos, so the answer will be 53.35. We're going to bring down 53 and make it degrees, and 0.35 times 60 will be 21 minutes. 53 degrees 21 minutes, and we're gonna name our P1 according to our D-long, so which is east. So we're going to subtract it by our long one, which is 70 degrees 40 minutes west. So the answer will be 17 degrees and 19 minutes west. So next, we're going to find our P2. To find our P2, we need to use the formula cos P2 is equal to tan L2 divided by tan LV. So tan 40 degrees 30 minutes divided by tan 45 degrees. So the answer will be 0.854080685. Shift cos, the answer will be 31.34. We're going to bring down 31 and make it degrees, and 0.34 times 60 will be 20.4 west. We're going to name our P2 according contrary to our D-long. Our D-long is east, so our P2 will be west. And then we're going to bring down our long 2 5 degrees 20 minutes west. Since they are both, we're going to add them 36, so the answer will be 36 degrees 40.4 minutes west. So next, we're going to find the initial course. So to find the initial course, we need the formula sine angle A is equals to cos LV divided by cos L1. So cos 45 degrees divided by cos 30 degrees 50 minutes will be 0.823498534. Shift sign, so the answer will be 55.4. And we're going to name it according to our L1 and our D-long. So it will be north 55.4 east. Since it belongs to the first quadrant, it will remain as it is, 55.4 degrees true. So next, we're going to find our final course. To find final course, we need to use the formula sine angle B is equals to cos LV divided by cos L2. So cos 45 degrees divided by cos 40 degrees 30 minutes. So the answer will be 0.929906935. So we're going to name it according to the contrary of our L1. Our L1 is north, so this is south. And we're going to name it according to our D-long. Same as D-long. So east. Since it belongs to the second quadrant, we need to minus it by 180 degrees. So this is the answer, 111.6 degrees true. So next, we're going to find the cos AV1. To find AV1, we need the formula AV1 is equals to cos AV1 is equals to sine L1 divided by sine LV. So sine 30 degrees 50 minutes divided by sine 45 degrees. The answer will be 0.724844555. Shift cos, the answer will be 43.54 degrees. We're going to times it by 60, and the answer is 2,612.4 miles. So next, we're going to find the BV2. And we need to use the formula cos BV2 is equals to sine L2 divided by sine LV. So sine 40 degrees 30 minutes divided by sine 45 degrees will be 0.918458238. Shift cos, the answer will be 23.30, and we're going to multiply it by 60. So the answer will be 1,398 miles. So next, we're going to find the P3. So to find P3, we need the D-long minus by P1 plus P2. So P1 is 53 degrees 21 minutes plus 31 degrees 20.4 minutes, because that is our P2. So if we're going to add them, the answer will be 84 degrees 41.4 minutes, and we're going to subtract 8 by 65 degrees 21 minutes. So the answer will be 19 degrees 21.4 minutes. So next, we're going to find the V1 and V2. So the formula is P3 times 60 times cos LV. Our P3 is 19 degrees 21.4 minutes times cos our LV is 45 degrees. So the answer will be 821.2 miles. So next, the last one, we're going to find the total composite distance. So to find the total composite distance, we need AV1 plus BV2 plus V1 V2. So our AV1 is 2,612.4 miles. Our BV2 is 1,398 miles. Our V1 and V2, our V1 V2 is equals to 821.2 miles. So if we're going to add them, the answer will be 4,831.6 miles. So that is our total composite distance. Thank you, sir, and that is my presentation. So now we're going to plot on Mercator chart. First, you need to find the longitude and latitude of the location. So when you find the latitude and longitude of the location, you can use two triangular rulers. You can use two triangular rulers to plot on the Mercator chart. For example, the first location is 9 degrees 51.5 minutes north and 125 degrees 28.3 east and the next location is 9 degrees 56.4 north and 125 degrees 24.8 minutes east. So you will know you can plot them by using. So to find the true bearing, you also need to use two triangular rulers to measure it from there to the compass rose. So that's how you're gonna find the true bearing. And to find the distance, if you don't have the right material, you can use a ruler and then put the ruler to the nearest longitude scale to find the distance. Please put in mind that the equivalent of 60 minutes is also 60 nautical miles, and the equivalent of 1 degrees is 60 nautical miles. If you know that, you can easily, if you know the conversion, you can easily know the distance. And that's how you plot on Mercator chart